My name is Claudia Mahlaule. I'm a development manager from the Johannesburg Development Agency, and I am responsible for the development in the inner city distribution services, which is part of the Rea Vaya BRT. We're just doing the whole resurfacing of the road, which we redid the layers so it can be able to carry the axle loading of the buses that are coming in for the Rea Vaya services.
This is where the prototype station is going to be. The tender for the award of the station's construction is far advanced, but that the award for the prototype station only has already been made, and construction will be starting on the 1st of September. At the moment, the contract is obviously gearing up, procuring materials and so on for the prototype station. The award for the bigger stations, for the rest of the stations that are required for phase 1A, is also fairly imminent, a week and a half away.
Around the 1st of September, they will be putting up the BTB layer on this section of the road, which is from there right up to the Delvers area.
What drives the whole thing is that the BRT buses, the articulated buses, essentially have 3 axles. One of those axles puts a point load of 12.5 tons. Now obviously the engineers who do the pavement design have got to take that into account. We've taken a very sort of long horizon in terms of the design life of the pavement. The pavements are designed to last 20 years. And so with the higher axle loads and the frequency of buses, obviously to maintain the required level of services, what our engineers then do is work out a pavement design. It's called a pavement design, call it a road design, that basically in most cases, in fact in all cases, indicates that we can't simply just put tar over the existing road and run the BRT buses. We actually, as the analogy that Mr. Steinway made at the press conference, you actually go in and take out the material that is not so suitable to carry the heavy loads and then build up. And typically, depending on what is underneath the new material that we bring in, typically your pavement design now becomes much thicker, 400 mils, 40 centimeters to sometimes even about 700 millimeters below the ground where we've got to go. Typically when the system is finished, what you will see is at the stations and at the intersections where these heavy buses now have to stop and pull off is either essentially a concrete apron or a material called salvesium, which is an asphalt impregnated product that basically has the characteristics of a rigid pavement, like a concrete pavement, because obviously the buses, as they brake and as they pull off, they exert the most forces on the road pavement. Obviously, you know, the city has taken the view that the BRT, they don't see it as a standalone project or just simply a transport project. And what we're really trying to do is integrate all these elements. And so to that effect, we've also appointed urban design engineers to look at, urban design architects, sorry, to look at land use, developing land use guidelines along the BRT corridors, to look at the treatment, the urban landscape in and around the BRT areas. And they are working obviously very closely with the Department of Planning and Urban Management in the city. And so in that way give the project a sort of much more holistic approach as simply just being a transport intervention.
What we'd be looking for is also to begin to build densities around the BRT routes. and particularly to work with our planning and housing departments, that housing developments are brought as close as possible. So that transit-oriented development, there obviously are land use guidelines for Gautrain. Similarly, our development planning urban management department is issuing land use guidelines for BRT routes. So it's not just a transport project, it's really a quality of life intervention for our own citizens.